In this video, we will do an overview of the locking mechanism.
One of the customer requirements for this project was to prevent the rover from tipping forward when the robotic arm on the front of the rover was outstretched. This can lead to damage to the arm, frame, and the internal electrical components of the rover. During past competitions, the rover team would have to position the rover in a way that would mitigate the potential for tipping. This would cost the team time, and it made it harder to use the arm. The Capstone team has designed a locking mechanism that solves this problem by freezing the rotation of the front bogies so that the rotation point is moved from the front bogies connection to the rover to the front wheels. This solution increased the force required to tip the rover from 580 inch-pounds to 900 inch-pounds, which will help the robotics team perform better in the 2022 Canadian International Rover Challenge this year.
Our solution replaces the rear swing arms with modified locking swing arms to prevent rotation of the front bogies. When the rover is being driven, a switch on the rover controller actuates a solenoid, pulling a pawl into the ratchet gear that is connected to the rover chassis. The solenoid mount and pawl are fixed to the swing arms, so when power is turned off, a compression spring will return the pawl to its resting position, allowing rotation of the front bogies. The geometry of the locking mechanism has been optimized in a way that maintains weight near the non-locking originals but promotes overall strength of the system. Locking rotation at this location is an effective way of increasing stability of the rover because it moves the rotation point of the rover chassis from the swing arm attachment points to underneath the front wheels. This makes tipping the rover over its front end much more difficult.